The vector cross product between two vectors is another way of multiplying vectors which returns another vector, whereas the dot product returns a scalar. Now the magnitude of this vector is equal to the magnitude of v multiplied by the magnitude of the vertical component of w, which is the magnitude of w by sine theta, where theta is the angle between the vectors. And because it's a magnitude, we take the absolute value of sine theta. So you can see that geometrically, the cross product gives the area of the parallelogram between those vectors. So basically the base by the height of the parallelogram. And the direction of this vector is equal to the product of the magnitude, but this time we remove the absolute value sign because the direction of the resulting vector is determined by sine theta. And the direction of vector r is perpendicular to both vectors v and w. So where v and w have components in the xy plane, the direction of r is along the z-axis, as indicated by the unit vector k. So the cross product is not commutative, because taking a cross product between v and w in this order, we take theta being positive counterclockwise, and if we take the cross product between w and v, then the angle between those vectors from v to w is clockwise, so we take it as negative, or minus theta. And we'll use the right hand rule to determine the direction of the resulting vector.